Hello and welcome. Smash like, subscribe. Today we're going to be doing a new series where we put our Boolean algebra skills to the test. So let's just jump right into it. Here's our first equation here. And yeah, we have three options to pick from, but I'm going to walk you through the process. So immediately what catches my eye here is this term, CAC. I know that this could be simplified to CA, and I'll explain why. There's a rule in Boolean algebra, I forget what it's called, but it basically states that anything ANDed with itself, or multiplied by itself, is equal to itself. And this is because in Boolean, the variable can only have two possible states, 1 or 0. Therefore, 0 multiplied by 0 is equal to 0, and 1 multiplied by 1 is equal to 1. Therefore, you can say C multiplied by C is equal to C. Therefore, CAC is equal to CA. So here's what our simplified formula looks like now. Our next step will be to multiply this C into this bracket. So each of these terms will be multiplied by C, meaning this term will be CAC, and this term will be DBCC. However, based on what we reviewed in the first step, Boolean algebra, anything ANDed with itself is equal to itself. So anytime you have a term like this or this, where you have two of the same variables, C in this example, you could simply eliminate one of them and it will have no effect on the final answer. So therefore, this C at the top is actually meaningless and doesn't have any effect on the final answer. So with that extra C out of the way, this is the equation we're left with. You can see it's just three separate terms all being added together. Therefore, these brackets don't really do anything because you can add things in any order and it's not going to affect anything. So this is our simplified expression here. And I don't see another way that we can simplify this. So I'm going to pick this as my final answer. So let's select this. And it looks like we got that one correct. So now let's move on to number 2. So here's our new equation. I think the best way to start will be to multiply this A into this bracket. So we'll have this term and this term will be ANDed with A. So we'll start with this term on the left. This will become A, C. However, we know that this is just AC. Why? Again, X and X equals X. If X is 1, 1 times 1 is 1. If X is 0, 0 times 0 is 0. So therefore, this first term becomes AC, and the second term will become AD bar. And this bar is just the not operation. So whatever this A and D turns out to be will become inverted. And to keep in mind, if you have things under an overbar like this, it's as if they are in a parentheses. Just something to keep in mind. Okay, so let's rewrite our simplified equation and move on from there. So here's where we are now. Still more stuff we can do. Let's just rewrite this to make it a bit cleaner and help us going forwards. We know that since we're just adding 3 different terms here, these brackets don't really do anything anymore because you can add things in any order and nothing is going to change. So I will erase these parentheses. And like I said, to keep in mind, this AD bar is actually in a parenthesis of its own. And we'll see why that's useful in a minute. So I'm going to rewrite the equation again. Now here's our formula nicely rearranged. And the next thing I want to do is look at this term here. AD bar. So not AD. And we're going to rearrange this so that we can simplify our expression even further. But in order to do this, we're going to have to look at something called the Demorgan's theorem. So the Demorgan's theorem states that AB bar is equal to A bar plus B bar. In other words, not A and B is equal to not A or not B. Now the way I remember it is split the bar and change the sign. Now I recommend you check out the Wikipedia page all about the Demorgan's theorem. Lots to learn. But in a nutshell, we can give it a quick proof with a few examples. So let's go. Case number 1, we'll say A is equal to 0 and B is equal to 0. So we're going to say that 0, 0 bar, and they're being multiplied. Let's just rewrite that. That would be 0 bar, which would be equal to 1. And if we rewrite that as in the second equation here, we'll say 0 bar plus 0 bar equals 1 plus 1. And in Boolean algebra, this gives you a 1. So far, so good. Let's say they're both equal to 1. So it's 1 times 1 bar equals 1 bar equals 0. We'll do it the other way. 1 bar plus 1 bar equals 0 plus 0 equals 0. So you can see it still works. Now let's say A is equal to 1 and B is equal to 0. So 1 times 0 bar equals 0 bar equals 1. And 1 bar plus 0 bar equals 0 plus 1 equals 1. And we can see that the answer will be the same if A is equal to 0 and B is equal to 1. So now that we know the Demorgan's theorem, we can continue with our example. So here we are. We're going to take our AD bar. We're going to use the Demorgan's theorem. We're going to cut the bar and change the sign. So this is equal to A bar or D bar. And we're going to rewrite our equation based on this. So the next thing we're going to do, again, is to multiply this A into this parenthesis. So our first term will be equal to A bar A. And think about this. What is the A bar A? There's a whole law about this in Boolean algebra. But if you just think about it, one of them is going to be a 1 and the other one's going to be a 0. So no matter what, you're multiplying two things with a 0. So it's just going to equal 0. And we can completely ignore this A here. So all we're left with is AD bar. So now let's rewrite the equation. And there you have it. Again, I don't see any other way to simplify this anymore. So we're going to see if this is an available answer. BC plus AC plus AD bar. And would you look at that? Nice, 2 out of 2. So far so good, but that's going to bring us to the end of this video. Hope you guys enjoyed and learned something. Smash like, subscribe, and we'll pick up where we left off on the next one. Thanks.